All right, we're recording. So, lesson 4, expected values. Expected value is an application of probability that involves the likelihood of a gain or a loss. Expected value is relevant in business, insurance, and in many situations in your daily life. The concept of expected value can be used to determine whether or not to participate in games of chance. Expected value is an estimate of the average gain or loss when participating in a game of chance. Here's the formula for expected value. Expected value is the probability of winning times how much you gain minus the probability of losing times how much your loss is. And there's two things I want to point out about this formula that need to be understood. Gain here is kind of the same thing as saying profit, which is equal to how much you win or how much you gain minus how much it cost. Right? If you're running a business and your sales turn out to be $100,000, that's not necessarily a profit. What if it cost you $90,000 to make that money? Well, then your profit's only $10,000. You have to subtract what it cost you to make it. The same thing is true in expected value for the gain part of the formula. The other part of this thing that I want you to realize is that this entire part of the formula here, this first part, this part here can be repeated. You'll see what I mean by that. I think in our second example. Our first example is very straightforward. There is a game that's being offered here. There's a 1 in 5 chance of winning $4. Notice it says 1 in 5. That's not an odds, that's a probability, 1 in 5. There is a 4 in 5 chance of winning $0, and it costs you $1 to play. So calculate the expected value of the game. Okay, so let's use our new formula. I'm just going to say EV instead of writing out the words expected value, if that's okay with you. So the probability of winning is the first part of the formula. Probability of winning. So what's that going to look like? Well, the probability of winning is right here, 1 in 5. Times how much you gain. Now careful here. How much I gain is 4 minus 1. Where did I get those numbers from? Well, the 4 is how much I won, and the 1 is how much it cost me to play. Get it? Cost, win. Okay, so that's the first part of the formula. The second part of the formula is the probability of losing. And let's see, well, there's a 4 in 5 chance that I'm going to lose. And how much did I lose? Oh yeah, my loss is that $1. Now, how's your fraction skills, everybody? I will admit I don't really care how you calculate this. If you need your calculator to help you with the fractions, you can. Those of you who are comfortable with fractions, you realize that this is a BEDMAS situation. 4 minus 1 happens first, right? 4 minus 1 is 3. And again, those of you comfortable with fractions realize that a fraction times a whole number, you treat the whole number as if it had a denominator of 1, and that's 3 out of 5. Top times top, bottom times bottom. Timesing anything by 1 doesn't change it. And then, what's 3/5 minus 4/5? Well, what happens when you take a bigger thing away from a smaller thing? You're going to get a negative. Negative 1/5. But this is a money question, right? This is all about money. So I'm going to change that to a decimal and put a $sign on it. And remember, there's a couple things I want to make sure you don't lose a half mark for. I know that if you punch in your calculator right now 1 divided by 5, your calculator is just going to spit out 0.2. But if you do this, that's going to cost you half a mark. How come? Because that's technically what we'd call a rounding error. I dare you to go out right now to the store and find me a price tag that says 0.2, right? 20 cents. There's always 2 decimals on money, always. You cannot leave me $0.2. If you looked at that and went, oh, I'd rather just write that as 20 cents, please write it like this. Don't give me this. Oh, wait a minute. That's not what I meant. Don't give me this. I get this every year from somebody. They said, but it's 20 cents. Is that how you write 20 cents? No, you've just written 0.20 cents. You've given me 2/100ths of a cent. You guys probably don't even remember what pennies look like, except that we flipped some in our probability activity the other day. But this would mean I'd have to cut a penny into 20/100ths of a penny. Just sit there with a little saw. This is not how you write 20 cents. This is. Okay? Make sure that that makes sense to you. I have to take off a half mark for things like notation errors, unit errors, errors in the way you communicate math. Right? This is not a technical math course like applied. It's not a theoretical math course like pre-calculus. It's the math we expect that every student could do in the real world past high school. The kind of math you do, kind of more everyday math. And in everyday situations, if you write down that, what are you talking about? Nobody's going to know what you mean. Nobody writes prices like that. So it is important that we communicate properly the way that we do math. All right, enough of that soapbox. Back to over here. If you're not a fan of fractions, by all means, alternate strategy for this question, I'm going to just put it over here. Or feel free to go right from here, right from this step here, and what is 1/5? Well, 1/5 is 0.2. And 4 minus 1, I don't think you need a calculator for 4 minus 1. What's 4/5? Again, put it in your calculator. It'll tell you it's 0.8 times 1. 0.2 times, and then run that through your calculator. 0.2 times 3 is 0.6. 0.8 times 1 is 0.8. And you get the 0.2 right away. But again, if your calculator spits out 0.2 and you write that down as your answer, slap a $sign in front of it, I got to take off the half mark. That's a rounding error. It has to look like that. Okay? So if you don't like working with the fractions, turn them all to decimals. We don't care, as long as you get the right answer. All right, this question is going to come up a bunch of times. What is this thing saying? What is this answer saying? Let me write it in words. Did you leave yourself enough room? Expect to lose 20 cents each time you play. That looks like I made you play one word. Let me write that better. I can do better. There we go. First of all, what told me that it's a lose? I look at this number and I know it's a loss. How do I know it's a loss? Because it's got a negative on it. A negative gain is a loss. Those of you who took essential math last year in grade 11, you did this in your finance unit, right? A loss is a negative profit. They don't make two different columns in the accountant's book for profits and losses. It's one column. The losses are negative profits. Here's the next thing we got to talk about. How could I play this game and lose 20 cents on a specific turn? I can't. I expect to lose 20 cents each time I play, but of course, that's an average. Just like the average number of kids in a family is 2.3. I have yet to meet the family that has 0.3 of a kid. That's an average. So I can't lose 20 cents on any particular turn, but my average loss is 20 cents. So that gets us to the B question. If a person played this game 50 times, let's undo that. 50 times 20 cents is equal to, I should leave the negative on it. Sorry. Can you fix that? There. 50 times negative 20 is negative $10. I expect to lose $10 if I play 50 times. Now, remember, the word expect is my theoretical probability. If we did this experimentally, if I handed out dice, we handed out some Monopoly money, and you actually played this game 50 times. Each time you played, you handed in your buck. Each time you won, you got given back the money. At the end of 50 trials for everybody, would everybody be sitting there with $10? No. One student might be sitting there with $8. The other person would be sitting there with $11. Somebody would be sitting there with $10.50. But if I did this lots of times, thousands of times, it would average to $10, right? That's that law of large numbers from lesson 2 kicking in. Note, keep in mind if you play the game only once, you either gain $3 or you lose $1. You can't lose 20 cents. You expect to lose 20 cents because that's an average. That's a dollar sign. Okay, we'll fill that in. All right, let's do a more complicated example. Oh, first a little bit of a note. In general, the following is true. If you play any game with an expected value of less than 0, by the way, is a fancy way of just saying negative, you expect to lose money. If you play any game with an expected value equal to 0, over time you'd expect to break even. If you play any game with an expected value greater than 0, which again is a fancy way of saying positive, you can expect to gain money. Every single opportunity to gamble that is run by a casino, by your government, by whoever, is a negative. There's people who go, well, what about blackjack? The dealer plays the game, you play the game, how could that be negative? Right? Don't you have just as good a chance as winning a hand as the dealer? Not necessarily, because what happens if it's a tie? The dealer doesn't pay you when it's a tie. You paid whatever $1 or $5 or whatever on that hand to try to win it, but it was a tie, they keep your money. So no matter how good a player you think you are, no matter how good your strategy is, you're delusional. The dealer has been trained by professionals and they have a better strategy than you. And if it's a tie, they win. Same thing with the roulette wheel. Doesn't seem like it, shouldn't the roulette wheel be a 0 game? You either bet red or you bet black. Isn't that a 50-50 odds? Isn't that a 1 out of 2 probability? Look at the wheel more carefully. 2 of the little squares are green. And unless you bet on the green, both the red and the black lose if it lands on the green. And that's going to happen, I think it's 1 out of every 36 times. The house will win. All professional gambling opportunities are negative for you. That's how they make money. So don't play them. Be smarter than them. Again, I fully expect someday a government representative to burst into my classroom and haul me off in chains for trying to convince you not to participate in government-run gambling. After all, our healthcare system would collapse if not for lotteries. So, oh well. Here's an interesting game. It cost me $3 for a ticket. There's a 1 in 10 chance that I'm going to win $25. There's a 2 in 10 chance I'm going to win $5. So there's a second prize. They're giving 2 prizes of $5 and 1 prize of $25. The rest of the tickets don't win anything. 7 out of 10 gets 0. And it cost me $3. So what's the expected value? So who's going to make money here, do you think? If my expected value is positive, the people playing the game should be the ones with the advantage. If the expected value is negative, then the people running the game are going to make the profit. What do you think just looking at it? Is this a fair game for the players? Meaning either 0 or they're going to be positive. Well, let's try it. Expected value is, okay, so what's the formula again? Look back. Probability of winning times what you win. Now careful, $25 is what you win, but remember it cost you 3 to play. Does everybody get where I got the 22 from? Even if I win the big prize, I paid $3. I'm only up $22. Does that make sense to everybody? Now remember what I said way back here? This, whoa, right here. This part of the formula here repeats. So I can repeat what I just did for my other chance of winning, plus a 2 in 10 chance of winning $5. Gee, Mr. Keller, that's a funny looking 5 you just drew. Why did my 5 become a 2? Because even if I win the $5, it cost me 3 to play, right? This 22 came from 25 minus 3. This 2 came from 5 minus 3. Does everybody get where that comes from? So if there was a third prize, I'd add another one. If there was a fourth prize, I'd add another one. I keep going till I'm done with all the wins. There can be multiple ways to win, but all the losses go into one part of the formula. There's a 7 out of 10 chance that I lose my $3. All right, can you tell yet? Is that going to look positive or negative when it's all calculated? No? Let's go to decimals for this one. 1/10 is 0.1, 2/10 is 0.2, and 7/10 is 0.7. If you need a calculator to help you do that, you can use it. We never take your calculator away in this course. Okay, 0.1 times 22 is 2.2. 0.2 times 2 is 0.4. And 0.7 times 3 is 2.1. Looks like it's going to be positive, doesn't it? And it is. It's going to be 0.5. And again, if you leave your answer like that, it costs you half a mark. Actually, that would cost you 2 half marks. It's rounded wrong, and it doesn't have a unit. It's money. What's the unit? $, and a 0. So, and then, you know what? This is a word problem. I might want a conclusion. Therefore, expect to gain, don't say win, say gain. Expect to gain 50 cents per game. If we play this game 50 times, we would expect 50 times 50 cents, which is $25, I think, right? Yep. So again, I kind of like a sentence to conclude with. Expect to gain $25. So this one was not fair for the people running it. If the people were running this game hoping to raise some money for something, they have done their math wrong. They are not going to win. They are not going to gain. Let's do one more. Actually, oh, sorry, we've got 2 more. 2 more examples. Then we'll let you have some more time. All right. I roll a 6-sided die. If I rolled an even, I win $3. If I rolled an odd, I win nothing, and it cost me $1 to play. This one I think you can tell by looking at it. Is this fair for the player? Is the advantage player or the advantage house? You think it's house? Isn't rolling an odd or an even the same probability on a die? Because half the dice is odd, half the dice is even. But notice it costs me less to play than what I'd win. Or let me say that again. It costs me more. I win more than twice what it cost me to play. Does that register with you? Okay, let's do the math. The expected value of this game, get rid of that. Expected value of this game, EV, I win 1/2 the time. Half the time I'll roll an even number. And I win $2, right? Because 3 minus 1 is 2. Minus half the time I lose, and I only lose $1. This is going to be advantage player. This is going to be a positive number. Again, you could switch to decimals if you wanted to, but I can tell you that 1/2 of 2 is 1, and 1/2 of 1 is 0.5. So this is going to be a positive 50 cents. Therefore, expect to gain 50 cents. This one turns out to favor the player. And here's that same question for part B again. Getting tired of this question. Suppose we played it 50 times. Well, that's the same answer it was before. 50 times 50 cents is equal to a $25. Again, expecting a $25 gain. All right, let's do one that's definitely going to favor the house. And this is exactly the kind of situation you might be in someday. Say that you're running the community club and you've been given a license from the city to run a raffle so that you can raise some money for your hockey team or something. Can you do the math that ensures that you'll actually make some money on it? Let's check out this one. This one's an arts group. An arts group got themselves a raffle license. And each raffle, here's what they've set up. Each raffle ticket costs $2, and the raffle consists of 2,500 tickets. One ticket will be drawn for the grand prize of a vacation package worth $3,000. Using a chart, determine the answer to each of the following. Determine the expected value of one ticket. So let's see. Now, if the arts group is going to raise money, this number has to turn out negative, right? It has to be an expected value on every ticket of negative so that the profit's going the other way to the people who sold you the ticket. So let's see if that's true. Well, you have a 1 in 2,500 chance that you are going to win the big prize. Now, I know what you're thinking. The big prize is $3,000. No, not quite. It's $2,998. How come? Because that's right, because the ticket cost me $2. My gain is $2 less because the ticket cost me $2. Now, that's the only prize. There's no second prize, no third prize. If there was a second prize, I'd have to add another and then add another for a third prize. This is just one big prize. Here's the part that yesterday nobody got. Everybody got this part. What's the chance, or how much do you lose on every ticket? Well, you lose $2. But what's the probability? What goes here? What's the probability that your ticket's a losing ticket? I'll ask you a simpler question. It's the same basic question. What's the probability that you roll a 1 on a die? What's the probability that you don't roll a 1? Right. Right? So same logic. What's the probability my ticket doesn't win? What fraction goes here? Think this through. What is the probability that your ticket, this is the probability of a win? What's the probability of a loss? What fraction goes there? No. The denominator is 2,500. Remember, it's desired over possible. If I'm counting how many tickets lose, what do I count to? That is exactly right, 2,499. Make sure that this makes sense to you. This is probably the toughest part of these questions. Do you get where I got that number from? If one ticket wins, 2,499 of them lose. Just like if one number on my die is a 1, 5 numbers isn't. Okay? All right, so make sure that makes sense to you. Okay, let's do the math now, or do the calculating. Want to go to decimals? Let's go to decimals. 1/2500 is 0.0004. I ran that through a calculator. I didn't do that in my head. Times the 2,998. Minus, and this is 0.9996. That's what this fraction here is. Times 2. And then I ran that through my calculator, and I end up with negative 80 cents. I had somebody ask me yesterday, it's like, if I'm good at my calculator, do I need to show you these decimals? Can I just run this whole part here through my calculator? And I said, yeah, go right ahead. As long as you show me those numbers and then you show me the answer, I don't really care how you calculated it. Don't just write down an answer, though. Show me the actual formula with the numbers in the right place. That way, if you punched buttons wrong, you goofed up the button punch, you'd still get most of the marks. Most of the marks is for the setup. I want to see that you're doing the formula right. Okay, so that's it. What is this saying? It's saying expect each ticket to lose 80 cents. That means if you're the Arts Council, every ticket you sell should profit you 80 cents. Okay, what if you bought more than one ticket? All right, well, if I buy 5 tickets, each ticket is a loss. I expect to lose $4. I expect to lose $4. How much were the arts group gain if it sold all 2,500 tickets? Well, for the arts group, 2,500, every ticket wins them 80 cents, right? Remember, for the group running the game, and again, most of the time we call that the house. It is a profit, not a loss. So that's why if you're wondering, hey, where did the negative go on the 80? We calculated negative 80. For the people buying the ticket, it's negative. For the people running the game, it's positive. They should gain, if you multiply that out, $2,000. Now that, of course, depends on them selling all the tickets, right? But if they do, that's what the total gain would be. All right. Stop my video.